Hello, so this is AQA Pure Core 1 Summer 2015 question 3. And this question gives you a curve and a shaded region, and it says the curve has the equation y equals x to the power of 4 plus 3x squared plus 2. And the points A, which is -1, 6, and B, which is 2, 30, lie on the curve. And part A asks you to find an equation of the tangent to the curve at point A. So this point. So to find the tangent, well, the thing is, if the curve is like this, well, something like that, and this is point A, then the tangent to the curve is the line passing through this at this point. So it's the equivalent of saying the gradient. So we know that we work that out. We know that we work the gradient out at point A by differentiating. So we want to differentiate y equals x to the 4 plus 3x squared plus 2. And so let's do this. dy over dx equals, right, this part times by 4 times by the power x, and then take 1 away from the power. Same with this, times by the power, 3 times 2 is 6, x, take 1 away from the power, so it's just x to the power of 1. And then 2, because there's no power of x, you times by 0 and it disappears. And then to find the equation of the tangent to the curve at point A, we just need to plug the coordinates of point A into this at this point, so the x coordinate basically, because there's no y in this. So we know that x is -1, the x coordinate is -1, so let's plug -1 cubed plus 6 times -1, and -1 cubed is -1. Be careful with all the minuses and pluses and such like, because it can really mess you up. So this is just -1 times 4 is -4, and 6 times -1 is -6. So we find that the answer is -10. Okay? So now, question B, part 1. The question is find the answer to this. So as soon as you see this little squiggly sign, you know that you're going to have to integrate, generally speaking, certainly in core 1. So let's just get straight in there and integrate it. So to integrate, kind of the opposite of differentiate, we're going to add 1 to the power. So this is going to become x to the 5, to the power of 5, and then divide by your new power. So the new power is 5, so x to the 5 divided by 5. And these are the limits, right? So it's important to keep this in brackets until you've utilised the limits. And then we're going to add 1 to the power here again, so 3. And then divide by our new power, so divide by 3. So 3 divided by 3, x to the 3, and that's still a plus. Okay? And then the 2, we're going to add 1 to the power of x, so that's just x to the power of 1, so just x, and divide by the new power, which is just 1, so it's just 2x. And then we have our limits 2 and -1. There we go, we've integrated. Now, to apply the limits, we're going to sub the top limit in first, in brackets. So we're going to go 2 to the power of 5 divided by 5 plus 3 divided by 3 is 1. So let's just cancel that out. So then we've got 2 to the power of 3 plus 2 times 2. Right? And then we're going to minus all of this with the bottom limit applied. Okay, so subbed in. So we have minus 1 to the power of 5 divided by 5 plus minus 1 cubed plus 2 times minus 1. Right? So, what does this equal? Let's just times it all out nicely. So we've got 32 over 5 plus, oh, this is cubed, sorry, plus 8 plus 4. So it's so easy to make little numerical mistakes, and they're such killers. So I think that when you're doing these A-level papers, particularly the pure core ones that have all these minuses and pluses and all sorts in, and cubes and squares, it's really valuable to read through every single question after you've done them. Even if you wait till the end of the exam and then read through it again when you've done a different question for a bit, and then go back to it and read through it, because if you spot something that you've completely missed out, then you'll feel so good for realising that you got it wrong the first time and you corrected it. Okay, so minus 1 over 5, minus 1, minus 2. And that all equals, if we times it all out and whatnot, that all actually comes to 21.6. So I hope that, or you can put it in the form 108 over 5, because fractions are encouraged. Okay, so I hope that was helpful, and thank you for watching. Bye.